Hi everyone, my name is Karen, and today I'm excited to share Listening to the Fishes. This project was developed in collaboration with Ilenia, an assistant professor at the University of Glasgow and director of the Animal Computer Interaction Lab, and Kaylee, an exhibit designer and fabricator at the New England Aquarium, and Professor Rebecca Kleinberger, who leads the Interact Animal Lab and taught the ACI course where this project began. For this project, we explored how we might design aquatic audio interfaces that let humans directly experience underwater acoustic environments, specifically from the perspective of fish living inside aquarium habitats. So, this project emerged at the intersection of several influences. As part of the ACI course, we visited the New England Aquarium, where Kaylee shared insights into the daily pragmatics of aquarium operations, such as how visitors interact with tanks. We were also able to consult Professor Philip Lobel, who specializes in fish bioacoustics, and he helped us understand how acoustically rich and acoustically vulnerable fish are, and how dramatically aquarium soundscapes can differ from natural ones. And from the Titmarsh Living Observatory, Brian Mayton's work on ecological sensing inspired us to think about sound as a tool for public engagement. All these perspectives help shape both the motivation and the design direction for our system. To start, I want to talk briefly about the motivation behind this work. So, fish are often perceived as silent, but many species are actually highly acoustic animals. They produce a large variety of noises that are used for things like courtship, territorial defense, to warn off predators and competitions, and for foraging. Because sound travels about 5 times faster in water and over longer distances, information actually plays a major role in their social and ecological lives. So once we understood that, it became clear how important it is to consider how human-made noise, especially in aquarium environments, might affect these fishes. So when fish are moved into captivity, their acoustic world changes dramatically. Instead of the natural underwater soundscapes they're used to, they become surrounded by sounds produced by things like the life support system, which includes things like pumps and aerators and chillers, which can all be pretty loud. Sometimes have a louder water circulation noise. And if there are like fans and HVAC systems or even like generators nearby, that can become pretty loud and the sound can reverberate into the tank as well. And of course, in settings like public aquariums, there's a lot of visitor generated noise, especially in the form of tapping. So on the left over here is a chart from a 1998 study by O'Neill, which is comparing the aquarium sound levels to those in natural environments. So over here, OBW normal, you can see that that's the sound, the noise spectrum in an aquarium exhibit, and Bay OS would be in uh, the wild environment. You can see that there's a quite a large difference, especially at the lower frequencies where a lot of fish are sensitive to. So, in many cases, these tanks do become surprisingly noisy environments for these animals that rely quite heavily on sound. So, many aquariums do try to reduce the amount of visitor generated noise by using signage. Here is an example from the New England Aquarium. Inside the red circle right there, you can see a small green sign. And here, as it zoomed in, it says, "Please do not tap on the glass, it disturbs the animals." So these signs do exist, but they're often quite easy to miss since they're like kind of small and sometimes out of the way, and they're often ineffective. So visitors still tap on the glass, sometimes out of curiosity, sometimes playfully, and oftentimes they do this without realizing that this noise can be stressful for the fish. So instead of relying solely on signage, we wanted to create like an interactive alternative, something that naturally redirects that tapping impulse away from these exhibits while fostering empathy and understanding. So for this project, we proposed an aquarium exhibit with three intended components. So on the left, we have component one, which is pre-recorded clips of fish sounds and some examples of noise pollution, which can be activated by buttons. And component two would be a hydrophone inside a live fish tank, which would be providing real-time audio of fish sounds. And separate from that is component three, an interactive tank, which would be a hands-on small-scale tank where visitors can create their own sound and hear that back in real time. This component should help mitigate visitors' desire to tap on component two to hear the feedback, which would bother the fish. For this pilot, we focused on implementing and testing the third component. So the pilot deployment featured a playful, approachable tank, which you can see right here, where a hydrophone disguised inside a rubber fish would capture underwater sounds in real time. Visitors wore headphones that were connected to the hydrophone, and as they interacted with the tank, like doing things like tapping or stirring the water, they would immediately hear how these actions sounded underwater. So the goal was to let people feel what fish experience acoustically rather simply be told about it. So we used an Aquarium H2A hydrophone. Thank you, Brian, for letting us borrow that. And it was encased inside a fish-shaped bath toy filled with water. You can see that on the top right corner right there. And in the left right here, we also provided tools like sticks of various materials and water that can be poured in the tank, and just various things that produce distinctive underwater sounds. So the setup was accompanied by a single researcher, and we deliberately avoided heavy instructions so that the interactions felt unscripted and exploratory, similar to how visitors might encounter an unattended aquarium exhibit. Visitors were invited to interact freely with the installation, and we recorded visitor reactions and comments as field notes. Here on the left, you see a classmate interacting with the exhibit during a test deployment we had in class. So for the official deployment, we did 3 public locations for a total of 6 hours. And across these deployments, we recorded 74 individual interactions, which gave us a rich data set, which we used for some thematic analysis. 4 major themes emerged from our analysis. The first being startle and sensory surprise. A lot of visitors were shocked by how loud even small actions could sound in the water. Things like a gentle tap, which might feel harmless in the air, became unexpectedly intense through the headphones. Another theme we discovered was social mediation and co-discovery. So people often explored the installation together. They would pass headphones back and forth and discuss what they heard and how they felt about it. And it really turned into sort of a shared discovery process. A third theme was active experimentation and play. Without being told to do so, participants systematically tested all the different objects on the tables. They will also try their own objects and other things such as stomping and shouting and shaking the table, essentially running their own informal experiments. And lastly, this was the most meaningful theme as well, was emergent empathy and reflection. So many visitors, after trying the installation, expressed a new understanding of how disruptive tapping might feel for the fish. We heard comments such as, "Oh, I would never tap on the glass again." And that shows that this kind of embodied experience created like a natural path towards empathy. Overall, our findings suggest that the installation was effective as an educational and engagement tool. By letting people directly experience underwater sound, we observed that there was increased empathy towards fish, and there was a potential for long-term behavior change based on the comments we received, and a natural redirection of tapping impulses away from live fish tanks and into like a controlled, safe environment. By immersing people in the acoustic world of fish, the system also encourages visitors to see fish as complex, sentient, and like communicative animals. And we feel that this shift in perception would help lay the groundwork for multispecies AI by inviting forms of interaction that are informed by animals' sensory experience. And that may eventually become even reciprocal. So there are definitely many limitations to our project. First of all, being that this was only a short and informal pilot, and there were only 6 hours of deployment, so not a lot of data right there. We also relied on field notes instead of like structured data capture, such as like surveys or audio or video recordings. So some nuances may not have been fully captured. And one important thing is that because fish have different hearing systems from humans, we cannot claim that this experience precisely reflects how fish perceive sound underwater. So there is still a lot that we want to explore. So moving forward with the project, we plan to integrate all three of the components of the system into one cohesive visitor journey. Uh, and also, we hope to be able to collaborate with aquariums to study the long-term impact of the installation on visitor behavior and wellness. Uh, our hopes for the project is that it would help develop soundscape design guidelines to improve acoustic conditions for animals in managed care environments, and also help us investigate the acoustic preferences and welfare indicators in vocal fish to ensure that the system supports their sensory needs. Lastly, we would also love to incorporate fish trigger interactions to enable a more reciprocal multi species ACI experience. Right. Thank you so much for listening. I want to acknowledge everyone who's contributed to shaping this work, including my co authors, the experts we consulted, staff and management who supported our deployments, and the many, many visitors who interacted with the installation. So thank you, and feel free to contact me if you have any questions.